Hey guys, welcome back to another week of ACES. I'm super excited for this week and our project, so let's start into it. So it's not really going to be a sciencey project, it is more of a electrical engineering project, but I am excited to show you guys. This week we will be making an electrical circuit. So the supplies you'll need will be in this baggie. So you guys got this brown bag last week, and it should have had this package and this package along with your DIY. Okay, so set all this stuff aside and we're going to start with our circuit. So in our circuit bag, we're going to find that we have one little container of Play-Doh, and it can be any color, a packet of clay, a 9-volt battery, 2 alligator wires, different colors for a reason, so keep that in mind. So mine are red and white. Yours might be yellow and green, black and red, black and white, any of those ones. And then one small LED light. So make sure to keep this in a safe place so we don't lose it. Don't lose it. So that's all we should have in our bag, okay? So the cool thing about this, what we're gonna do this week is we're gonna figure out how electricity runs from this battery through alligator wires to Play-Doh into the light bulb. And so to do that, we're gonna test 2 different ways of doing it. One way we'll do it with clay, and the second way we'll do it with Play-Doh. So let's start with clay. First things first, I want you guys to unwrap your battery, because this still has a plastic wrapping on it, and you'll need it to be unwrapped. So go ahead, there we go. Do it. You might need to use some scissors, or not. Okay, so we have our battery. And the part that we'll be using the most is this part right here, okay? So the bigger circle is gonna be our negative, and the smaller circle will be our positive. You can also tell what it is by looking at the battery. And right here it says positive and negative, so you'll know what you're gonna hook it up to. Okay, the next thing you're gonna do to prepare our experiment is get out our clay. Now you'll need enough clay to make 2 balls that our light bulb can be stuck into without touching each other. So about yay big. So about that big. So no, you don't have to pull out all the clay. But if you want to play around with it for a little bit, then go for it. It is kind of fun to touch. Okay, roll it up into a ball. Okay, so I have my 2 balls right here, and I'm gonna make this one a little bit smaller because I want them to be equal. Okay, so I have 2 equal sized balls right there, almost. Okay. And now I'm going to grab my light bulb, and I'm going to put it into our Play-Doh, or not our Play-Doh, our clay. I'm putting it into our clay already. So go ahead and do that. Now, for this experiment, it doesn't matter which side goes into which, just as long as it's in there. Now, what I want you guys to do is see your alligator wires. So one side of the clip, one side of the clip is going to go onto the battery, and the other side will go inside the clay, okay? So let's click our red one to our negative and put it to right here. And for guys, whenever we're putting our clips into Play-Doh or the clay, just go ahead and stick it in there. It's kind of hard just to like clip it onto the clay because it's so soft and malleable. So just go ahead and stick it in there. And for our other end, we are going to grab the clip. Let's do it this way so that we can see what we're doing. Now make sure it's to the point where it's not touching the clay. The clay and Play-Doh cannot be touching whenever we're doing this experiment. So we're gonna clip this end to our positive, and then the other end of the alligator clip into our other Play-Doh. And as you can see, in our clay, when we put it on, it makes our light bulb turn on. Now I don't know if you can see if my light bulb is on. Let me try to turn off this light so you can see. Give me 1 minute. Okay, so you can kind of see better that I turned on. I'm gonna take one out so you can see. So as you can see, the light turn on, and then put it back in, and it turns on. There we go. Let's show you up close. There we go, and there we go. So this is our air dry clay. And let's try with our Play-Doh. So let's take out our clay. Now the cool thing about this air dry clay is that both clay and Play-Doh have a certain ingredient in it that makes the electricity run through the clay into the light bulb, and we'll see why in a minute. So let's test our Play-Doh. So we know the air dry clay works. Now let's just try and see what happens with our Play-Doh. Okay. So we're going to take 2 little balls again, like we did before the clay. We're gonna grab our alligator clip, stick it inside the ball, and we're gonna hold our other ball. Red alligator clip inside the ball. In there, we're gonna grab our light bulb and make sure they're not touching, and go ahead and insert the light. Ooh, so you can see it's not turning on. Hold on, there you go. Whoa. So as you can see, it's a way stronger connection. So we have our Play-Doh and our clay. So in these things right here, there's a certain ingredient that there's more of in this and less of in this. Now in some clays, there's none of this ingredient at all, and the light bulb will not turn on. And that ingredient is salt, I believe. And salt is a good electricity conductor. And so whenever they put salt in the Play-Doh, it helps electricity run through the Play-Doh into the LED light bulb. Now, say if this clay didn't have the salt, the electricity would be running from the positive side of our white alligator wire into the clay, okay? And because this Play-Doh has a salt that can conduct electricity in the Play-Doh, it goes straight into the light bulb and then out into the other Play-Doh bulb, into the red wire, and then back into the battery again. So it's kind of self-sustaining, so it's going back and forth, back and forth, back and forth. It's an ever-ending cycle. Now, if this clay did not have salt in it, and it would have been regular, just regular modeling clay, regular modeling clay does not have salt in it. And so when the electricity would go through the white wire, it would hit the clay and it would stop because it would not be producing enough. So all the electricity that was going to this would not flow from here because it stopped it and there's nowhere to go from there. Okay? And same thing with this side. Because electricity couldn't run through the positive side of the play ball, it wouldn't make it to the red part, so the light bulb therefore wouldn't light up. But with ours, we lucked out and found that there's a little bit of salt in this one, and we know that because the light turned on a little bit, but not as strong as the Play-Doh did. I can't talk as always. So another thing I want you guys to try is to do one piece of clay and one piece of Play-Doh, and that way we'll see what happens. So we know that the clay has less of it helps conduct electricity at a lower strength, but we know the Play-Doh helps conduct electricity at a stronger rate. So I want you guys to see what will happen if you combine both, so clay and dough, if you combine both of those and see what will happen. So let's do that. Let's go ahead and take our white alligator and our red one, and then we're gonna just remove this one to the side, and we're gonna go ahead and make another ball of clay so that we can try this out. I'm actually gonna have you guys make 2 more balls because I want you guys to see the difference. And okay, so this one right here, that one right there. So you can tell the difference between the light strength and with the clay and the Play-Doh. So you can see it turns on, but it's very dull, very, very, very dull. But then if you insert it into the Play-Doh, it is very strong. And that's because it has electricity to run through and burn. So let's try. See how bright that is? It's crazy how bright it is. How it gets. It's because there's so much salt in it. Yeah. So we've done that. Now we're gonna try the part where we do one Play-Doh with one clay and see what happens. So as you can see, it's kind of running through really well, but it's kind of in the middle now, so it's not as strong as Play-Doh and Play-Doh were together. So now we know that. Now another thing I want you guys to try with this experiment or this little building project is my class learned that if you create 3 balls of Play-Doh, there is a way to turn your light back on and off, okay? So whenever we do it this way, and we have them connected and we put in the alligator, it stays on. But there's no way of turning off your light, right? So what if you, maybe in the future, not saying that we are going to, but what if we in the future kept the supplies in our supply box, our toolbox, and I provided more supplies for you guys to make a cool nightlight? You guys would need a way to turn off your light. So one way that I figured out we could do that is if we take off the alligator wire and we connect this alligator wire to this ball of Play-Doh right here, okay? So this will be like our on and off switch, and this will be our light. So keep in mind that our 2 balls of Play-Doh are not touching, and that the light bulb is still in the 2 balls of Play-Doh. So we have, and our white alligator wire is not connected like it was before. I'm gonna grab this ball of Play-Doh and touch it to this clay. And do you see how that turns on and off? With me just touching the clay to the Play-Doh to the other Play-Doh. That's a way to turn it on and off. So say we made a night light in the future, we could create this as our night light, and then this would be our on and off switch. And we would turn on our light at nighttime and leave it just next to it, making sure it's touching the whole time. And then in the morning, just move it over. Isn't that awesome? I think it's pretty cool. So, the next thing I want you guys to see is, I'm going to take out this white alligator rod and put it back next to our circuit to make the full circuit. And right now, when the light is on, our Play-Doh balls are not touching. As you can see, there's a huge space in between. But if we make them get closer and make the Play-Doh touch, you see that we've turned off the light. And that means, guys, and the reason for that I want to explain is that whenever we have the Play-Doh balls away from each other in more space, the only other way for electricity to run to is up this little, I can't tell, is to run up this little metal piece right here into the LED light and out the other side. But when the Play-Doh is touching, electricity is running through the Play-Doh. So we touch it together and it turns off. Now, it doesn't need to go through the light bulb to get to another place. It can just go straight through the two balls of Play-Doh. And so I take it apart, there's no other way to get through, so it goes through the light bulb. Isn't that cool? So basically, light bulbs are just a way of making electricity run through another current really quickly. And that's our little experiment and project for this week. You guys have successfully learned how to make a light circuit kind of thing with the battery, alligator wires, Play-Doh and or clay, depending on the kind of clay. I believe this is air dry clay, so that's why it worked a little bit more, because I had to put salt in it to make it dry in the air. But if you use regular or moldable clay, the light bulb will not turn on, and that's because there's no salt. And so I think it's a really awesome thing to do and to learn, and hopefully maybe if you guys, I would love for you guys to save these supplies. Obviously, because this purple clay is not salvageable, it's air dry clay, so it won't stay good for a while. You would have to get rid of that, but we can still use the Play-Doh. The Play-Doh doesn't dry up if you leave it into the box. So put your Play-Doh in your yellow container and put it in your toolbox, along with your 9-volt battery and your alligator wires. Because I would love to build on this project and maybe do that project that I mentioned earlier about the night light. That'd be really cool, and it'd be really awesome if you just saved it so you guys have these supplies already that you would need. Okay, so go ahead and put these in your toolbox and save them for later, because we will be building on this. And I will see you guys next week. It is going to be changed up a little bit. It's going to be less engineering and sciencey and more cooking and artistic. So I'm excited for that. I'm excited for you guys to see this different but cool project for next week. And yeah, I will see you guys later. Bye.